In the question number 11, a uniform cylinder of mass 10 kg and radius 1 meter rolls without slipping on rough inclined plane of inclination theta. The minimum value of coefficient of friction is mu. So in this kind of question, I would like to suggest you can save your time. Mu minimum. You can learn, I would like to suggest 10 theta upon 1 plus r square upon k square. So I would like to suggest this short trick. So in this type of question, you need only the nature of body, moment of inertia about center of mass, that is 1 by 2 mr square. If I compare with mk square, where k is the radius of gyration, when you will compare these two, you will get k square upon r square, that is 1 by 2. So if I go for r square upon k square, this is 2 by 1. So you will place only the value 10 theta 1 plus r square upon k square is only 2. So very quickly you will get 10 theta by 3. So this is how you can deal this question. So option number 3rd will be the right choice. Let's move on question number 12. In the question number 12, if at depth h acceleration due to gravity decreased by 25%, you should keep in mind 25%, as compared to surface of earth, then at the height h it will decrease by in comparison with surface of earth. So you can compare with value of g in surface. So in this type of questions, first, as per the scenario, 25% is going to decrease. So when you will take the difference between surface and, as per given the situation, 1 minus 25 upon 100, you know very well 25% means 1 by 4. So when you will subtract with the full value, you will get 3 by 4 g naught. G naught is the value of g at the surface, and in terms of depth, you know the formula h by r. So g naught will cancel. When you will calculate, you will get h is equal to r by 4 by this relation. So that was my step number 1. Now, according to the situation, if I go at h equal r by 4, so I am going to use the relation g naught r square upon r plus h, and value of h is r by 4 with the whole square. I am going to use the formula of variation in g. So when you will calculate, r will cancel out. So you have 16 upon 5 g naught, and this is the value of g. But I am looking to find the change. So delta g means g naught minus 16 upon 25 g naught. So when you will calculate, you will get 9 upon 25 g naught. But I am looking to find the change in percentage. So we'll write delta g upon g into 100 for percentage. So 9 upon 25 into g naught already was there. अब डिवाइड करोगे जी नॉट से, इनिशियल वैल्यू है, इंटू 100. जी नॉट विल कैंसिल आउट, सो यू विल गेट 36%. So in the question number 12, my option number 2 will be the right choice. So let's move on question number 13. Question number 13. Let Earth to be a perfect sphere of radius RE. Now a platform is arranged at a distance 3 by 2 RE. From the center of Earth, the escape velocity of a body from this platform is n times of VE. E means escape. From the surface of Earth, the value of n is. So in this type of question, I am going to use the law of energy conservation. So if I use, first I will write the potential energy at the surface of Earth, and that will be minus GMEM RE. But according to the problem, we'll write 3 by 2 RE, and the second one is kinetic energy. But on the final kinetic energy and final potential energy, in the case of escape velocity, infinite position means there is no potential energy and no kinetic energy. We'll write 0. So when you will calculate this expression, you will get the value of V, and that will be 4 times of GME, mass of Earth, divided by 3RE. And if I write like that, root of 2 by 3 and 2 GME upon RE. And why I am doing this? Because I am looking to make a formula just like escape velocity. So you will write here root 2 by 3, and this is the value of escape velocity. Will write here. So this is my equation number 1. If I compare this relation with the given condition, and that was n times of VE, this is equation number 2. So you can compare equation 1 and 2. Easily you can get the value of n will be root of 2 by 3. So my option number 2 will be the right choice. So let's move on question number 14. In the question number 14, a uniform rod of length L, cross-sectional area A, Young modulus Y is stretched by applying two forces F1 and F2 as shown in the figure. The elongation in the rod will be F1 is greater than F2. In this case, elongation when forces are different at two ends. So I would like to suggest you can memorize this result directly. F1 plus F2 divided by 2 into L and Young modulus into A. This is because you know, and I would like to suggest there is no need further calculation. When you will face this type of question, when both are stretching, there will be no change in the bottom portion. So you can memorize this result. F1 plus F2 by 2 initial length and divide by the Young modulus into A. So you can get option number 3rd will be the right choice. So let's move on question number 15. In the problem number 15, a liquid mixture of volume V has two immiscible liquids of density ρ1 and ρ2. If the mixture density is sigma, then mass of second liquid in mixture is. First I will write the total mass, and you know mass is given by density into volume. So in the case 1, ρ1 V1, and in the case number 2 it will be ρ2 V2 divided by the volume V. And we know V is equal to, if I go V1 plus V2. So V1 will be equal to V minus V2. And this is my relation number 2 and this is my relation number 1. So first if I go in this result, then we'll write sigma into V, ρ1, and I can replace the value of V1 by using equation number 2. So we'll write ρ1 V minus V2 plus ρ2 into V2, and this is the equation. By this relation, I am looking to find the value of V2 because my target is to find the mass of second one means M2. So when you will rearrange this equation on solving, you will get the value of V2, and that is sigma minus ρ1 upon ρ2 minus ρ1. You can easily solve this, and this one V2. Because you are looking to find the value of M2, so mass is given by volume into density, and now I had the value of V2 by this calculation, so that will give you ρ2, and value of V2 is sigma minus ρ1 divided by ρ2 minus ρ1. So this is how you can calculate mass M2. So my option number 1 will be the right choice. Let's move on question number 16.